Hello everyone, welcome to tutorial SVM part 3. In this tutorial, I will show you how to convert the C code that we generate before from the MATLAB into the VHDL code or IP code with a high-level synthesis. In this tutorial, we use a new code that basically is similar with the previous code in the part 1 and part 2, but here I just have 30 data for each speech. Previously, we used 50 data for each speech, but after I generate the VHDL, it took a lot of utilization area. And now I reduce into 30, but everything is similar. Here, the C code that we generate before, we can see the C code here. It has a similar criteria with the input of 32 data, and then the output is still the return labels in the float type. And here, we can simulate the C code to see what is the behavior of the C code. Here I prepare the main.c. It's basically generated by the MATLAB, but I made some modifications. Here I supply this test with the actual number that's got from MATLAB here. Here the MATLAB data row. I use this data to actually test this function in the C code, because previously we test in the MATLAB code. And now we try to run this code. Sorry, this data is for 4 speech, so number 4 speech. It's 32 data. We open the terminal to run this C code. Here we use a GCC compiler. Yep. And then we see the result. And the result is 4 for this data. And then what if we change this? Give the comment here and we uncomment this data. This data now it's for number 1 speech. So we run again with GCC, then we see. Okay, the result is correct. So this function is ready for doing the HLS process. And then we open the Vitis HLS software. The software is basically free, and you can download and you can try the software. Feel free to generate your C code into HDL. It's good to generate basic first and then become the more complicated the next step. Here, create a project. We will save the file in the similar folder that we generate the C code HLS. Okay. Speech with 30 data. I will publish the code in the GitHub. Don't worry. Here in the first step, we need to include the C code data. So C for HLS. Actually, we can select all of this, and then we exclude the file that we don't need. For example, the main.c, main.h, and main.x. But here is still a lot of file that we don't need actually, but it will be ignored by this software. Don't worry. Then we select the top function. This is the top function of the function that we want to generate in the VHDL. Here attachments, you can add the file of main.c and main.h. This is for testing, but it's not mandatory. You can skip, it's no problem. The parent here, I just use 100, and the part device here, I want to select the RTZ7. Here RTZ7. Yes. Sometimes the HLS process will take so long time for processing. So be patient in this tutorial. Maybe you can skip some part to accelerate this. And then here we can see our C code. Yep, exactly similar. And then here we can open the setting first. And then we can do the setting for all of the parameter. A lot of parameter that you can set here. I usually make this 120, and a lot of parameters such as the pipeline or the FIFO type and so on. Here this is called simulations, but we don't need the call simulation actually. And implementation, I will prefer with the VHDL here. And we said later that you can ask and then search in Google what is the parameter instead this you can set. Here what I usually do, I specify the directive. Here we have the input of 32 data with a float type, then the output return with the float type. I don't want to make this a sport digital input because it takes a lot of input then, because float is 32-bit, then 32 by 32. It's huge number for port. So I will use the Axilite interface communications. So here for main function, we specify we add Axilite. It's more convenient to have Axilite to use it in the IP core. Here, because it's 32, I will make categorize with each of 8th input. So I will show you this bundle will specify you can make a classification here bundle. For example, here from input 1 till 8th, I use input part 1. For example, like this, and so on. I will make it 4 part. This is in Accelerate. Lot of option that you can choose here. In the mode you can use stream master stream also. Accelerate is the basics things that you can use, and it's commonly used for IP core communication. Part 3. So you can specify actually a lot of directive for HLS, but it's convenient to just leave it default if you don't know what should you put in the directive. Here I have I had experiment before, and then this is my setup for this. So the directive for interface has been done set, and then now we do the run flow for doing the synthesis. It will take some time. You can skip this part because I would not edit. By the way, the main reason why I set the period into 100, I start with the high period, which means it's a low frequency. It's around 10 megahertz because based on my experience in these projects, it takes a lot of things to in the digital. So if we set in the short period or high frequency, it will give like violation in slack time. Yeah. Here it's a synthesis. Synthesis is done, and then now we can see the utilization here. So for the SVM speech for 30 data training, we got the LUT or lookup table, then flip-flop here, ESP and locram, and there is no violations. The slag is normal, and then we can see the as axi register. Here in the axi control we have the application return this offset. It's access just read because this is a data signal for return signal, and this the data 1 to 32 we got a map for each data here, and then yep, everything on right is here. Actually you will get the more accurate utilization after you do the run implementation, but I will not showing you the implementation here because it will take more long time, so I will skip that part. I can show you the result of the HLS process here. Here the VHDL code that you can use. Yes, this is the VHDL for SVM speech with the 30 data training. A lot of things and so complicated. We will not explore this. But for export the IP core, you can click the export RTL and you will get the IP core that you can use. I will show you how to use that in the next tutorial video. And then, okay, that's all. Thank you. Bye.